For over 100 years, our industrial machine and our economy have been dependent upon oil. Until alternate energy sources are developed, oil will remain vital to America's strength. Never easy to find, petroleum resources are increasingly scarce, and maintaining supplies requires constantly improved recovery techniques. Some that are being used to get at oil in existing wells, oil that was out of reach before. Most U.S. crude oil is recovered through unique production techniques. Methods that bring oil to the surface after natural pressure in a well is depleted. One of the most productive of these, developed in recent years, is the injection of liquid carbon dioxide into wells where secondary methods like water flooding are no longer effective. Familiar to everyone as the fizz in soft drinks, CO2 thins the oil in porous rock formations and dissipates the solution with its bubbling action, allowing the oil to flow for recovery. In the mid-1970s, Shell Oil Company began planning for one of the largest carbon dioxide injection projects ever conceived, to tap immense CO2 reserves in southwestern Colorado and transport it by pipeline to West Texas, where over 1 billion barrels of crude oil awaited recovery by this method. Pooling their resources, Shell, Mobil Oil Company, and Continental Resources Company formed the Cortez Pipeline Company to build the largest capacity carbon dioxide pipeline in history. Because of the size and complexity of the job, Cortez turned to Wilbros Energy Services of Tulsa, Oklahoma, the most experienced pipeline contractor in the world, having built more than 100,000 miles of pipeline in 44 countries during their 75-year history. Similar to the frontier railroads of a century ago, Wilbros constructed the pipeline in two converging spreads. The northern spread, originating near Cortez, traversing the rugged high plains of the southern Rockies and crossing the Continental Divide, while the southern spread headed out of Denver City across hard-pan plains country through southeastern New Mexico. Meeting near Albuquerque, they completed the 502-mile pipeline. Like railroads, pipelines require right-of-way easements. Advanced planning assures the line follows the most direct route. This historical narrow-gauge railroad has been traveling the same right-of-way between Durango and Silverton, Colorado for over a century. That's the kind of safe, economical, dependable transportation that pipelines deliver. But unlike the railroads, pipelines traverse country that no other form of transportation can handle. For over 75 years, Wilbros crews have been doing just that, and sections of the Cortez pipeline were as challenging as any they'd ever met. After laying 5 pipelines across the rugged Andes Mountains, Wilbros knew the critical importance of route selection to every pipeline operation that would follow.
You're aware it's going to be tough to get in here unless we're able to come through your road down there.
Okay, we can come in here through the gate, up the road around the hill, and then we can give you some access up through this canyon here to you. But I believe we can work something out on that. Sounds mighty good. Thank you for coming by.
Thank you.
Carefully marking the exact pipeline route, surveying crews were fully aware that tons of heavy equipment would soon have to make it through here. In fact, at that very moment, 2 columns of Wilbros equipment were en route to the Cortez project. One from Watertown, South Dakota, after completing a major 42-inch diameter gas pipeline.
Yeah, when you're doing all those small roads, you're going to have to go.
Another from Stillwater, Oklahoma, leaving behind one more major water transmission project by Wilbros. The Cortez line goes through topographic formations ranging from topsoil to solid rock. Over 40 million cubic feet in all had to be excavated and replaced according to strict requirements. A mammoth undertaking. Rotary trenchers made it look easy. They're capable of displacing about 5,000 cubic feet per hour, depending on rock density. And they cut the ditch to finished depth in one pass through the New Mexico caprock, completely eliminating drilling and blasting in this area. Planning this kind of performance into pipeline construction has made Wilbros a safety award-winning contractor. In other areas where topsoil was to be replaced, trenchers worked in pairs, one removing topsoil and the other completing the ditch to specified depth. Throughout the trenching operation, existing lines were successfully located and avoided. No small task in areas like the southern kickoff point near Denver City, where nearly 400 feeder and trunk lines were encountered, many carrying lethal sour gas. While the trenching was underway, other crews were busy with pipe arrival and handling. From the Santa Fe yards in Galveston, Texas, pipe sections were transported to the coating yards in Albuquerque, New Mexico. Specially modified flat cars moved the pipe in unit trains up to 52 cars long. For protection from corrosive elements of the soil, every section of pipe was coated. 300 miles of it with extruded polyethylene butyl, and the remaining 202 miles with hot applied asphalt enamel. Once coated, pipe sections were hauled on special steering pole trailers to field stockpiles, and then on to the right-of-way for stringing along the ditch line. Stringing logistics were complicated by requirements for placement of different wall thicknesses of pipe on various sections of the Cortez line. Ranging from about 5/8 of an inch to 1 inch thickness, pipe joints were manually welded according to strict codes and specifications. At stockpiles near Roswell and Vaughn, New Mexico, special welding racks made smooth work of double jointing operations. Using a standard submerged arc process, 3 automatic outside passes and 1 internal pass produced the longest double joints in pipeline history, 120 feet in length and weighing up to 19 tons. Effective pipe stringing had each section alongside the ditch, awaiting the next crew at the right place. To conform to the right-of-way and the topography, bending was a frequent requirement, one that took precise advanced planning. On the rugged terrain of the northern spread, nearly every joint of pipe had a bend of some kind. Side bend, over bend, or sag bend, while the southern spread saw miles of straight joints. On all field wells, a revolutionary compound bevel devised by Wilbros was used to reduce the amount of weld metal required. Formed by special milling machines, the bevel has a 1/16-inch vertical land, a 30-degree bevel for approximately 1/2 the remaining thickness, and a 20-degree bevel the rest of the way in. In Dolores, just north of Cortez, the first day of welding begins at this northern kickoff point. Initial welding passes, the root or stringer beads, were made while pipe sections were cradled by side booms and precisely aligned with a pneumatic clamp inside the pipe. Coincidentally, this microwire process uses carbon dioxide gas to shield the welding arc from normal atmosphere for a stronger bond. Then hot passes with welding rods were made for the fill and cap welds. On thicker joints of pipe, up to 12 passes were required to complete a weld. All field wells were inspected by radiography. Using an internal crawler, single-wall X-ray exposures were made of each joint and then processed in the field for immediate evaluation. Constantly threatened by corrosion, these critical wells were protected by polyethylene heat shrink sleeves or asphalt enamel. To ensure complete integrity, every foot of pipe was carefully inspected with holiday detectors to locate any bare or damaged areas in the coating. Mute sentinels of ages past, cliff dwellings in Mesa Verde National Park, Colorado, bear testimony to man's early progress in these locales. Known only by the Navajo word for ancient ones, the Anasazi people thrived here against all odds over 1,000 years ago. Nearby, on the precipice of Cherry Creek Canyon, unique pipeline construction techniques were put to work. Up here, at the highest point of the Cortez route, 8,300 feet above sea level, pipe sections protected by banded blanket asphalt were eased down from atop the mountain with help from a specially engineered winch assembly. Once the pipe sections were welded and coated, lowering in followed. Paying careful attention to the existing environment, backfilling and cleanup crews followed close behind, leaving the land in as good or better condition than before the construction. During the job, rivers, highways, and other crossings were finished using special engineering skills and construction techniques. River crossings on the Cortez Pipeline presented another challenge to Wilbros crews.
Come off that bank over yonder. And we'll start with a 235 backhoe on the other side of the swamp.
The route of the line crosses 4 major rivers: the Pecos, the Rio Grande, the Animas, and the San Juan. Seasonal rains and spring runoff from winter snows can swell these rivers to over 2,000 feet wide. Cold winter weather was endured to make the crossing at the optimum time. But strong river currents kept sweeping bottom silt back into the ditch. Drag lines scooped deeper to compensate. Work progressed slowly, and crews didn't dare stop at day's end. At dawn, the equipment was refueled, and another long day commenced. Slowly crawling into position, this formidable line of equipment and suspended pipe are edged toward the bank for lowering in. Finally, she was across, and tying in operations began. When the valves and scraper traps were installed at the specified points and hydrostatic testing was completed, final preparations for carbon dioxide transmission were made. Inner pipe surfaces had to be protected from corrosion by drying the line to a dew point of -40 degrees with hot air injection and by shooting a series of drying pigs through the length of the pipeline. Capable of pumping 650 million standard cubic feet a day, its enhancement of recovery will provide benefits well into the 21st century. Wilbros does much more than build pipelines, though. The company's experience and rugged determination have been diversified into oil and gas drilling, specialized engineering, and construction management services, adding exciting dimensions to its energy service capabilities. Based in Midland, Texas, Wilbros Drilling serves the oil and gas industry with medium depth and deep capacity rigs, currently operating in the Permian Basin of West Texas and southeastern New Mexico, as well as the Anadarko Basin of western Oklahoma and the Texas Panhandle. From their headquarters in Tulsa, Oklahoma, Wilbros Butler Engineers offers worldwide services, including engineering inspection, materials procurement, and complete project management.
Thanks, Tom.
How far is it across there, and then we put the valve on that side?
The river's about 50 feet.
Worldwide, the company has long been known as a leading builder of pipelines and related facilities and a supplier of services to the energy industry. Wilbros International Incorporated, through its various subsidiaries, has worked in every climate and terrain, including the frozen Arctic, the jungles and mountains of South America, the deserts of the Middle East, and the jungles and swamps of Africa, building enough pipelines to circle the world over 4 times. When you have an energy project to complete, rely on the proven professionals who have served over 300 clients in the energy industry worldwide for over 75 years. Call Wilbros anytime, anywhere.